All right. Good morning, good afternoon, everyone. Thank you very much for joining us here at HashiCorp and some of the great folks at AWS for our session today around unlocking the cloud operating model with AWS and kind of a future look into next ops. For our session today, we've got a senior practice leader over global DevOps at AWS, Kelly Looney, who I will turn it over to shortly. During the session, we do have the availability for Q&A. So as questions come up, please feel free to put those into the window. I'll be moderating questions, and then we'll have a good Q&A session at the end. And with that, Kelly, I will turn it over to you to get us started today.
Thanks very much, Chris. Appreciate it. Thanks, everybody, for joining. Just want to talk today a little bit about where are we going, kind of in the world of software, what's operations going to be like, where are we going with the cloud. Start off a little bit just with, who am I to talk about where software is going? I'm a person with about a 30, 35-year background in software development. I've been around software development about as long as we've been doing software. Started out doing good old waterfall style type of development for a good solid 10 years, but actually got involved in the small talk community fairly early on, and about 20 years ago. And from that, learned a little bit about this kind of idea of incremental development and growing your software rather than building it like a building or like a bridge, but actually growing it in kind of an incremental way. The other thing is that I've been very lucky in my career. I've had a chance to work with some of the people that actually pioneered a lot of what what software is about. People like Kent Beck, people like Adele Goldberg and Kenny Rubin, a lot of the people out of the small talk community. And then later, as I got involved in kind of the DevOps world, people like Jez Humble, Damon Edwards, Luke Holman, all sorts of folks there as well. So it's been it's been great to be able to work with people like that and to be able to learn a lot from them. And what I want to do here is show you what I've learned since coming to Amazon as well. And about 2.5 years ago, I joined Amazon, and coming out of this, having worked with organizations doing DevOps, helping them with their software development over time, it was my first time in actually seeing an organization that was imbued with this style of development, from all up and down the stack. And what I want to do in this presentation is give you some ideas from some of that I've seen from some of the leaders at Amazon. And the first one I'll talk about is Jeff Bezos. This is a representation of the, like a lot of startups. Jeff started Amazon with a kind of a napkin diagram. He kind of talked about this sort of kind of innovation flywheel that Amazon put together of how they wanted to create a growth through constant customer feedback, be able to constantly give people more selection, constantly give people lower prices, and give them more and more selection. And this is sort of his sort of idea of what he wanted to do. And the idea was to constantly give feedback. And what was interesting about that is that he kind of created this idea of an organization that was constantly learning. And what's interesting about that from a kind of a DevOps standpoint is that's really the key. I talk to a lot of customers about DevOps, and they think that it's all about simply automating, and they think that it's a matter of, I just need to automate delivery. And really what I try to get across to people is that the automation is a byproduct. The idea is really, can you get answers to questions? And so let me show you another version of that napkin, and that's what I call the kind of innovation flywheel that we're trying to put together for DevOps. And that is, how do you constantly put ideas out there into experiments such that you can get feedback. And this is what we try to do all the time, kind of in the DevOps world. And automation is really a byproduct of sort of process. And that's what we're really trying to do. And what you see at Amazon today is constant new features in production, constant new features in delivery, where we're trying new things, trying to get feedback, and constantly trying to answer questions. So it's like, how quickly can you ask questions and get feedback? That's the real point. And believe me, automation will come out of that. I mean, that's part of what you've got to do to get the questions answered. Now, there's another leader I want to talk about at Amazon that I really enjoy, and that is our CTO at Amazon, Dr. Werner Vogels. And what I love about Werner is that he has this great talent for encapsulating huge ideas in the smallest number of words possible. And so in the rest of this presentation, I'm going to present a few quotes from Dr. Vogels. And what I want to do is show you how he's able to take a very small number of words and really capture a really, really big idea. So here's the first one. You build it, you run it. Well, I think that's pretty much DevOps in a nutshell. And that's what that's the way we've been living within Amazon for quite some time. The whole idea is whatever team builds something new, they need to expect to be able to run it over time. They don't give it to somebody else. It's not you build it, somebody else runs it, or somebody else builds it, you have to run it. It's you build it, you run it. And so that affects the way you build it. It's very much of it's really interesting. Once again, small number of words, it means a lot. And so it really affects the way you do everything. And these are the ramifications that DevOps kind of has. And I'll talk a little bit about how we at Amazon, have had to build up an organization that allows you to actually do this, because this is what all startups kind of have to do. Okay, you have to build it and run it because you don't have enough people to do anything else. But when you build a huge organization that has an enormous number of regulations and enormous security requirements and everything else, if you still want to do this, you've got to figure out a lot in order to get this done. So let me talk a little bit about how we go about still doing you build it, you run it in Amazon. And so we kind of break this into a couple of different pieces. For us, there's organization, but for us, when we talk about organization, what we're interested in is autonomous pieces that are designed to be self-sufficient. We want our organization to be broken into lots of autonomous pieces. And, there's an idea that's talked about a lot out there there's a law called Conway's Law, which says that when you build systems almost always look like the organization that created the system. And so our architectures tend to mirror our organization. And so we want organizations that are filled with autonomous pieces. Our architectures are the same way. So we try to build an architecture with lots of decoupled small little pieces. That's kind of sounds like a architectural concept we hear a lot about these days. I'll talk about that in just a minute. And then we have this idea that, you hear a lot in organizations out there about process. And a lot of times that's really kind of an overbearing concept. It's lots of rules we've all got to live by. And big companies have to have a lot of process. And we've got a different word that we use within Amazon. We have something which we call mechanisms. And that's our style of processes. And the way I would talk about mechanisms is that mechanisms it's how we make it hard to do the wrong thing. We try to create a situation that kind of moves us towards doing the thing that makes sense for the organization. And we try to do it with tooling, with service levels, with the way we scale, everything that's in there. And so it's our variation on processes that helps us move in the right direction. And then finally, somewhat famously in Amazon, we have our culture. And one of the things that's interesting about our culture is that it's written down, and it's our set of leadership principles. And I'd really invite you to do a little bit of research on the Amazon leadership principles. Everybody that interviews with us has to kind of bone up on those and learn about them, but they're way important past the interview process. They're really the way our whole organization works and speaks, and the way we measure everything that we do. And so we have written down, it's almost like a constitution for us. We've written down what we value at Amazon in our leadership principles. And so it's really, really important for you to look at what kind of person we want, how we want to do things. So with this cultural philosophy in place, we put a bunch of practices and patterns in use, and then we start building tools that all support this. So this is how we empower what we're doing in place in order to make things happen. And then the other ingredient that's very important to get things done is obviously pizza. Pizza is key. The other thing I'd say there is, somewhat famously, you may have heard of this already, we very early on found that for productivity, it was important to keep our teams small. And our sort of rule of thumb on this was something we called the 2-pizza team. So the idea became that if we made teams that were larger than what a couple of large pizzas could feed, our teams were probably too big. And so that became sort of, once again, kind of the rule of thumb. You know, get people in a room, a couple of large pizzas, maybe 7, 8, 9 people. And it's interesting, we early on came up with this rule of thumb. We started building teams of this size, and this idea has scaled. And within Amazon today, there are thousands upon thousands of 2-pizza teams. It makes it somewhat frustrating to find the team you need to work with within Amazon, because we have thousands upon thousands of them, as I said. But it's great from a standpoint of you have a small team to work with, and you can get things done. The communication overhead is never that great. From a historical standpoint, the way Amazon started doing DevOps, we started doing it before DevOps was ever really even coined. Around the 2001 timeframe, we had a large monolith application. Amazon.com. It's a large monolith backed by the traditional relational database. It's the way everybody built things back then. We had one big database, we had one big application, we had hundreds of developers all working against that, and it was a huge ceremony, a huge amount of work in order to make any sort of a change to that. We had to replace the whole thing. It was very cumbersome. At that point, there was sort of a top-down edict that came. This is kind of lost somewhat in the midst of legend, but Jeff Bezos came out with a memo and basically said, we're going to do what I would call a top-down directive to be bottom-up. We decided to move to a service-oriented architecture model in which we decided every one of our teams, which, as I said before, are these small 2-pizza style teams, would start to work to build pieces of software that were surrounded by public interfaces. So we kind of broke our monolith into 100 different pieces that were each supported by small teams writing software surrounded by public interfaces. And so in this time frame that I talk about 2001 to 2009 roughly, we broke our monolith into hundreds of different pieces. Today, that's many thousands of pieces. What's interesting about this is that this model has continued to scale. We've kept building in this way. We've kept adding what I'd call these, instead of service, just SOA services, these are really microservices, because the teams are small. We found that making the services smaller and smaller made them better and better. And so we really started working in a DevOps style because we made these teams very self-sufficient. They did everything from planning all the way through to delivery, all the way through to operations. And they made very, very small services. So they were doing microservices before the term was even coined, and they were doing DevOps before the term was even coined. And so this style of doing things has worked for us ever since that time frame. So from 2001, we started the process all the way to today. This has been our style of work within Amazon. The two pizza team, the dev team builds a microservice and they work for a customer. And what's interesting about this is that these teams, sometimes their customers are external customers and sometimes they're internal customers. Sometimes they're really working just to a metric from a standpoint of they're trying to adhere to an API or just to a particular metric on that API. Sometimes they're working directly to a customer interface or something that's there, but they are all simply building to their particular service interface. There's no silos. Each team has the skills inside of the team to build everything that they need. Now, does that mean that every team has deep expertise in all areas and everything possible? That would be that's not possible for them to all has to support these teams. And so what used to be silos, at Amazon, we've got world-class security people, world-class database experts, so on and so forth. Those people either moved into teams or they became support organizations that supported teams and mentored and trained teams to be able to actually deliver on products. So that's really, instead of silos that have the ability to say no to delivery, you create organizations that are able to support teams that do delivery. And that's really more of the style for DevOps. So some of the guidelines and the kind of the way that we worked, we break up all of our activities into services. Every team exposes its data only through interfaces. No team communicates directly to another team's data. This is really, really important that each service had its own data that it kind of owned. You could use any technology you wish. So we use a lot of different languages and a lot of different technologies for our different services. It just depends on what makes sense for your problem. We don't have people kind of on high that make decisions for you on what technology makes sense to solve your problem. We feel like the people that are closest to the problem should make technology decisions for solving a problem. And then you design interfaces for externalization for the people outside. So, we've kind of got this feel for what modern applications look like now. Today a modern application is uses these independently scalable microservices, and what's come out now is we've got technology to hold these microservices. We've got container technologies, things like Docker containers or micro VMs, such as what we use in our serverless technology as well. So new things have come about to actually help make these things more and more secure. We're connecting through APIs. We have this ability to deliver updates continuously. We have the ability to scale globally. We have the ability to make these things fault tolerant and carefully manage state and persistence. That's one of the interesting things about, back from my days of doing objects and whatnot, one of the things that made objects difficult to scale was that objects had state. Now we've learned that keeping state out of objects and keeping them in separate databases allows us to almost infinitely scale a lot of these objects. And so having security built into these modern applications as well as part of kind of the part of the infrastructure, part of everything that's there. So these are kind of all the attributes of modern kind of technology. But there's one issue about modern applications that really is a major gotcha. You know, as you build these microservices types of applications, they get enormously complex. They multiply hugely, and this is the one thing that when I go out and I talk to customers a lot these days, and they're for instance incredibly enthusiastic about, you know, jumping on the Kubernetes trend. Kubernetes is fantastic technology, absolutely love it, but jumping into a complex distributed microservices application, if you're not used to dealing with that sort of thing and not used to debugging an application like this, it's no picnic. And so I really encourage customers to get the proper tools and the proper skills in place to get yourself ready to deal with these sorts of modern applications. There's a lot to it, and there's a lot of lessons that we've learned over time in what it takes to be able to deal with modern applications. And let's go back to Werner and see what he's got to say as far as some of the lessons learned on how to deal with modern applications. And here's one right here. I love this quote. Everything fails all the time. You know, I think for a lot of time in operations, our whole focus has been on avoiding failure. You know, I think the whole there's been whole realms of there's been whole industries have been are set up around how to build software or how to build hardware that doesn't fail, or you know, how to avoid failure this way or that way. And you know, I think what Werner's saying here is a much better attitude for you to take is that things are going to fail, and so you better be ready for failure. That's a much better attitude to take rather than I'm going to avoid failure. I'm going to make sure failure doesn't happen. Much better to build your system in such a way that you can deal with failure. Certainly, there's a huge need out there for agility and resiliency. You know, IT failures today are having broad societal impact. You know, obviously IT is everywhere. There's reputation and legal issues, huge dollar issues related to lost productivity. You know, the time spent putting out fires and recovery, lost revenue. I mean, obviously it's a huge issue that kind of to deal with it. So you know, and huge amount of money is spent on building systems that are on kind of putting together, especially hardware that is resilient. The question is, can you create software that's resilient? And so here's some of the things that we've learned about software that's available, reliable, and resilient in the 21st century. You know, you gotta be able to test your recovery procedures. You gotta be able to automatically recover from failure. You gotta be able to scale horizontally to improve availability. You gotta be able to automatically scale. You don't want to guess capacity. You want to be able to automatically add capacity as you need it. And you need to be able to manage change through automation. You can't manually do changes. That's what has to be automated, is actually doing your changes. Some of the anti-patterns out there that we see, some of the issues, some of the problems that we see that people run into, especially as they go to this new cloud operating model that they're running into, is replicating on-premise problems as they go into the cloud. Okay, the cloud gives you a new paradigm, and if you simply replicate what you had on premise in the cloud and don't take advantage of what you've got in the cloud, it can give you, you know, you're not reaping any benefits. Using non-redundant architectures in order to meet schedules. Single data center architectures, using those in the cloud. And then reusing manual processes, data retention practices, so on. Responding to monitoring alerts and metrics manually rather than using self-healing or auto-scaling types of functions that you can build in. And then just assuming that your data is safe in your data center. I think that premise, we've learned very effectively that premise is not effective in telling you, whether your data is safe. You just simply can't sacrifice long-term value for short-term results. That's the main thing that we found from a standpoint of what these anti-patterns tend to tell us. Another thing that's kind of interesting about kind of distributed systems that you've got to get used to as you're moving to these new sorts of systems and moving to cloud systems is, not only are they complex, but distributed systems are kind of strange. We're used to software. Much of the software that we've built over time is meant to either run or not run. It's meant to either work or not work. It was designed to be either up or down. And the problem for a lot of software out there is that, in a lot of distributed systems, you've got this issue of it can be in a partial state of degradation. In fact, a lot of distributed systems are almost always somewhere in a state of degradation. And that can lead to all sorts of unknowns that you may have to deal with. And this goes back to Werner's quote, everything fails all the time. There's some part of your system that may not be working, and you need to have a system that can still operate even if part of it's not working. And so that requires software to be a little bit different. One thing that I think may be of help, just at reInvent. Hey, folks, I'm back. I hope you can hear me.
Hey, Kelly, we can hear you loud and clear.
Oh, sorry about that. Everything fails all the time.
Resonates perfectly with the message.
There we go. That came back fairly quickly, though. That was good. So anyway, I hope I was talking about Amazon Builders Library, and this is a case of our sharing a little bit of our practices. I would encourage people to go and visit there. This is something that we're continually adding to, and it's something that I have wanted us to do for a long time. And I'll just leave that there. Go and take a look. It's us sharing some of the ways that we've been building cloud systems for a long time. So let's go back to Werner one more time as far as a little bit more of his wisdom about kind of where things are going as far as the cloud. One more quote from him. No server is easier to manage than no server. So you might think of this as strictly talking about Amazon's serverless product offerings. And certainly that's part of what it's talking about. But I would say that the other side of this is that I think that for much of our industry, we've been out. We've thought of operations as this part of the organization whose job it is to kind of mind infrastructure and watch hardware. And I would invite you to think that that's probably not going to be the case any longer, or much longer at all. I think that in the future, operations is going to be something different, and our serverless offerings are just one of the things that is letting you know that that's the case. And so I think that in the future, operations is going to be about managing software rather than managing servers or hardware of any kind. And so I would recommend that people think in those terms. So let's talk a little bit about let's unpack a little bit of this statement. Yes, when we talk about serverless, one of the things that I like about serverless is it actually is technology that to some degree enforces a lot of the things that we've been asking people to do. I've been kind of recommending people do for a long time, which is write in small, understandable lines of code or understandable units of code. You know, when you write a Lambda function, it's a small, understandable unit of code. It's stateless. It uses consistent networking and infrastructure. It's an event-driven application that's easy to deploy and secure. These are all things that we've been wanting people to do anyway for a very long time. The advantages of it is you don't have to manage the servers behind it. It's automatically high availability. It's automatically flexible scaling. So you really get some great benefits to it all. You know, I really think that it gives you some great advantages. Some of the use cases that we've already seen out there, and this is just growing and growing, the sorts of things you can do. You know, everything from web applications through IT automation. The thing that I think is beautiful about serverless is that you can get started small, and just like my original example of Smalltalk, you can start very small and incrementally build and build and build into more complex things from there. We've got a full platform of different offerings, and our friends at HashiCorp have added to this with a lot of new functionality that they work with our serverless offerings as well. So we've got a kind of a complete set of tools, and many of our partners add to that as well. Now, if we were a normal technology company, we would just say, hey, everybody should go serverless. But we're not. We're more about customer choice. That's part of that. Goes back to the original napkin that I showed you before. We believe in customers having choice and deciding what makes the most sense for them generally. And so we also are determined to have the best container offering out there. So we offer two, you know, in the cloud, we have a basic data plane of EC2, and we offer two different orchestration layers for containers. For a application that is a core cloud application that uses AWS services, we believe that Docker containers, Amazon ECS gives you the best scalability and is the easiest thing to use. If you want to use stock Kubernetes and you want to run things both on-premise and in your data center, which is a use case that we'll talk about in a minute, which is something very much the cloud operating model that HashiCorp is helping to focus on. Amazon EKS is a perfect orchestration layer. I think that makes a lot of sense in that sort of a situation. And then added to that now, we're also offering a serverless way to run Docker containers, such that you don't have to worry about doing hardware infrastructure on top of all of this. So just a few recommendations here, just from a standpoint of where we're going from a standpoint of operations. I really don't think in the future running software without understanding that software, I don't think that's going to be a thing. I think operations is going to be about understanding the software you're running. Infrastructure is going to be fairly invisible. And I think that monitoring, logging, observability tools are going to be where operations lives and works. I think watching running software, looking for ways to make it better, is going to be what your best technical people are doing. And I think that tools like HashiCorp's set of tools are going to be partly what you're going to be using to do a lot of that work. And I think that SRE activities are going to be operations job one, whether or not you actually have SREs on your team. We at AWS don't typically have the role of SREs. We do that within our DevOps teams. Remember, you build it, you run it. And so we do our own SRE work within our teams. But the key here is instead of reacting to software problems, you want to be proactive because everything fails all the time. So you want to be proactive. So finally, the thing I want to do is talk a little bit about this whole cloud operating model and how this sort of unlocks and how this especially fits with what HashiCorp is doing. We've got this whole transition happening right now from a traditional data center, which is more static and dedicated infrastructure, over to a modern data center that's more dynamic, that involves public cloud and private cloud. You know, I'll say this from before my time joining AWS, that I think that most of the private clouds that I saw organizations attempting to do were not very successful at all. I think now organizations are having more success doing private cloud, but they're doing it kind of as an adjunct to public clouds. They're doing things like VMware in an AWS data center. I think that's a more effective way to do a private cloud than anything they ever were able to do as private clouds inside their own data centers. So these new hybrid models where you, excuse me, where you obviously have to have some things still in your on-premise data center, and then you're starting to use the cloud to grow everything that you're doing from there is where we're really seeing things go. These systems of engagement, they're going to be in the cloud, and they handle the spiky access patterns. They handle this sort of dynamic kind of growth that you see as things happen. So you have core things in your traditional data center, and then everything that grows and adds will be outside in your cloud. All your systems of engagement, everything where there's lots of customer interaction, time to market imperative and frequent iterations. Really all those places where you're asking questions and doing exploration. A lot of the stuff we talked about at first that are these critical business functions that are helping you be competitive. So implications of this cloud operating model, there's these dedicated servers that you're provisioning in your static on-premise versus your on-demand heterogeneous servers that you're provisioning in your dynamic cloud. There's your security that's IP-based in your static data center versus your identity-based, lower trust servers in the dynamic cloud. There's the host-based connectivity versus service-based connectivity. And then dedicated infrastructure in your on-premise versus scheduled across the fleet systems that you run in your public cloud. And you see some of the technologies that get used here. vCenter and versus vSphere, and then EKS and ECS for provisioning. IP versus identity, all sorts of different hardware, and then vSphere versus EKS and Lambda. is kind of the cloud landscape that's there. And then the one thing that we'll add to this, we'll kind of talk about, there's a case study that HashiCorp has put together where they worked with a major telecom company, and they took a system or they took an application delivery model that was taking about 22 plus weeks to actually be delivered, going through and working in their kind of on-premise environment. And they were able to help them move this over into this sort of combination on-premise and cloud type of environment with a set of their tools. They're able to utilize Nomad, Council Vault, and Terraform, utilize all of them in this same model that we've just talked about, and take it down to 5 minutes to be able to implement a new change and do all the things that we just sort of talked about as far as a rapid sort of answering a question, doing a new kind of a delivery. And I'd invite you to go out and take a look at a little bit more of this this example out there on HashiCorp's website. It's a very interesting kind of a case study that's out there. So thanks very much. Sorry for that little glitch where I had my failure happening all the time. And go build out there. Thanks very much. So let's answer some questions now. Chris, you got any interesting questions?
Yeah, absolutely. So one of the questions that came in, just kind of a quick, easy one is there a centralized registry of the APIs used by each of the microservices kind of across AWS that somebody can dive into?
There's a couple of different ways of doing that. And AWS is such a large organization that there's various groups and there's various registries of those. But the answer is yes. And there's a couple of different places where you can search through and find things. I always get this question about, oh my gosh, what if there's duplication? You know, what if I go build something that already exists? And the one thing I would say about that is that there's a story where Jeff Bezos got up on a whiteboard and wrote, he wrote 2 is greater than 1 on the whiteboard in answer to a question of whether he was worried about duplication of effort. I'm sorry, he wrote 2 is greater than 0. And what he was trying to say there is that he's less worried about duplicating than he's worried about spending so much time worried about duplication that you get nothing done. And so it's a matter of, it's okay if 2 people build similar functionality. You can always go back after the fact and make sure that maybe those 2 things get pulled together into one later. Or maybe one modifies their microservice such that it can handle both requirements. He'd much rather have each group making sure that they satisfy their customer. But there's not any one tool that we've gone out with we opened up to customers or anything like that. There's several homegrown internal kind of library types of things. Famously, I'll go back to my Smalltalk days. That's what the original Smalltalk browser was all about, was sharing. It was one of the great examples of sharing code interfaces. But no one that we've opened up to the outside world yet, but several internally.
Excellent, thank you. Another question that came in, this is kind of along the containers line. So how do you keep data encrypted within the containers or make sure the containers are not in a shared compute state? Right, and so being able to gain visibility across data, just making sure that there's no leaks. Any kind of tips and best practices you can share on that side from a security point of view when it comes to containers?
That is not a great area of expertise for me. I think that we've got a few. I'm not going to speak out of turn on that. I'm not sure if AppMesh helps in that, or if there's something else that makes sure that we encrypt everything in transit. I'm fairly sure there's some technology for us to encrypt all the data in transit that's there. We have both technology for encrypting everything at rest and everything in transit, but I'm not going to speak out of turn and tell you the wrong thing.
Yeah, no, and that's great. And also for the person who asked that question too, in our cloud operating model white paper between AWS and HashiCorp, we have some things that start to scratch the surface here that talk a little bit about the shared responsibility model across AWS and HashiCorp and how we're leveraging Vault across a myriad of plays for security issues like this. There's also a couple of dedicated resources across HashiCorp site properties, primarily Learn, where you can dive in and kind of learn a little bit more towards that. We'll work on compiling some additional documentation in terms of looking at container plays with AWS as it pertains to the security piece. Also, there's been a lot of questions that have come in around, will this presentation be available and will everybody get slides? Yes, we will make this available. We'll have that turned around. So just keep an eye out for that, and it should be available in your email after the session has concluded.
Awesome.
Yeah. And I think that actually takes us to our time today. And we've got about 45 minutes scheduled for the presentation. So Kelly, thank you so much again for the time today and for presenting with us and also helping us, build the cloud operating model together with AWS and roll this out for customers. So again, thank you so much for the partnership. And everybody, thank you again for the time today and for joining our session with Kelly Looney at AWS.
Thanks all. Appreciate it.